Hi, welcome to the demo for PyGraphia, which is a Python library that I wrote for implementing graph algorithms out of the box. It comes with a lot of graph data types like graph, vertex, edge, walk, path, and it has a lot of algorithms also implemented that we can use to build any applications related to graph, whether it's a GUI application, whether it's a command line application, and even a web application. Basically, it's library that provides you with graph things out of the box. So this is the source code repository for the library, and the library itself is hosted on the Python packaging index, which is the official repository for Python packages. As you can see, it's in early development phase, and if you go to the release history, as you can see, the release version is a pre-release version, so it cannot be used in production. It has a lot of bugs, it has a lot of rough edges, but it kind of works if you know how to make it work. So we can install it using pip with this command. I will be copying it to my clipboard, and we'll be jumping into a project to demonstrate how it works and its features. We'll be implementing this graph. As you can see, it's an weighted undirected graph. So we will be creating a demo directory, and let's cd into that, and I'll be creating a virtual environment using Python's built-in ven. And while it's creating, let me show you some of the things that it offers. Currently, as of now, it provides the following algorithms that are the breadth first search, depth first search, and MSC generation algorithm. The MSC generation algorithm is implemented with frames right now, but in the future, I'll be trying to implement more algorithms so that you have more choice. So now that we have created the virtual environment, let us activate it with the command bin activate, and we have now activated the virtual environment. Now let us install the dependency here. It's almost 20 kilobytes, so it should not take long for installing it. As you can see, it just got installed. It's just 21 kilobytes. So now we can create a file to demonstrate the features. So let me create a test.py, and here I will be implementing this graph here. All right. So first we will have to import the library into here. So we have the PyGraphia. As you can see, it like it came into the suggestion box, and it has two modules. The core and algorithms will be requiring the core, and from core we will first need vertex. As you can see here, that it has a vertex, edge, path, walk, and graph as its like main data types. So first of all, let me use the vertex here. From vertex, we will be importing the vertex class here. Now we will be also requiring the graph to implement the actual graph here. From the graph, we can import the graph class. All right. So first of all, the way this library is built is that you can create separate vertices. You can create separate like edge types. You can create graphs. You can then like allocate some vertices and edges to a particular graph. So we will be requiring to create the vertices separately, and then we will attach like attach those vertices to the graph. So first let me create a vertex that is 0, vertex 0. So as you can see here, it requires these parameters for initialization, that is the label and whether it is directed or not. That directed parameter is an optional one, and it is set to false by default. So I'll be giving it a label of 0 to represent this edge here. This vertex here. So here you go. To save us some time, I have already like written them over here. We will just copy paste them here to save us some time. So we have these vertices here now, v0, v1, v2, v3, v4 to represent the 5 vertices here. Now what we will do is we will create the actual graph. We will call this graph test graph, and we'll use the graph class. Now The graph class actually does not require you to send any vertices in the beginning, but here, because you already have the vertices with us, we will just send a list of these vertices and create the graph. We will initialize the graph with these vertices. It also has optional parameters like whether it's a directed graph or not, but because the default value for directed is false and we have an undirected graph here, we need not provide it. So here I will just create a list of all these vertices v3 v4. Now that we have the vertices attached to a graph, what we need to do is we need to make the edges. Now how do we make the edges? We can just write test graph dot add edge. As you can see, it also has a add vertex method which you can use to add more vertices if you like, if you need to make any changes to your graph later on. For add edges, it takes, it takes source parameter, a destination parameter, and a weight parameter. So for source, I will be because this is an undirected graph, we need not like differentiate between source and destination. They can be both used interchangeably. So for source, I'll be writing like v0, and for destination, let me write v1, and the weight will be 10 here. So again, to save us some time, I have already written these here, and we can just copy paste them. We can check that these exactly represent this graph. Now we have the vertices and we have the edges to represent. We have everything that we need to represent our graph actually. So what we can do is now we can check out the various properties that this graph has. Now this graph has various properties like, oh, is it an Eulerian graph or not, is it a connected graph or not, is it a cyclic graph or not, and various properties like these. We can test them one by one with if blocks. Like if our test graph is a connected one or not, is connected, then we can just simply print that our graph is connected graph. Otherwise, we can just print that the test, we can just print that graph is not connected. All right. Now we have, I think we have a file. We can run it and see whether it's a connected graph or not. So as you can see from the diagram, it is quite obvious that you can go from any given vertex to another vertex of the graph. So it is a connected graph indeed, and that's what our like property says us. Now to save us some more time, I have already written quite a few if blocks for our testing purposes. So I'm sorry. Okay, let me go to the next line, and here I have quite a few if blocks to check all its properties. So as you can see, we have properties to check whether it's a regular graph or not, whether it's a cyclic graph or not, whether it's a tree or not, or whether it's Eulerian or not, and a few others properties actually. So we can indeed come here and like test. So as you can see, it is a connected graph. It is not a regular graph. It is a cyclic graph. We can see we have cycles here, and it is not a tree because, of course, it's a cyclic graph. It cannot be a tree, and it is not an Eulerian graph. So we have these here. As said before, it also comes with a bunch of algorithms as of now. So here we'll try out the MST generation algorithm here. So for the MST generation algorithm, we need to first import the function, that is if from PyGraphia.algorithms this time. From MST, we have to import the get MST function. So for doing that, the get MST function actually returns a tuple. The tuple consists of the edges of the formed MST and the cost of the MST. So we can do here get MST. As you can see, it takes two attributes, that is a graph and an optional starting index. We won't give a starting index. In that case, it will just go with the first vertex that we added to the graph. Anyway, let us give it the parameter test graph here. So we'll be printing. You can just print the edges directly. It will print nicely with representative edges between them, and we can print the MST cost. You can also write like here, the cost is this. This is the cost. Cost is the MST cost, and this should give us the MST edges and the MST cost. So now let us try this out. And here we can see that these are the MST edges that we get, that is 0 from 2, from 2 to 3, from 3 to 1, and from 3 to 4, that is our MST. And the cost of this MST is 15. You can't get any lower than this. That is the minimum weighted spanning tree of this graph. So as of now, these are all the features that it has. I know it is it is currently a very small set of features that it provides, but I am planning to add more properties and more features in the coming days. So thank you for listening, and have a great day.